And station, this is Houston. Are you ready for the event?
Station is ready for the event.
Everyday Astronaut, this is Mission Control Houston. Please call station for a voice check.
Station, this is Tim Todd, the Everyday Astronaut. How do you hear me?
Tim, I hear you loud and clear.
Fantastic. Don Pettit, the legend himself. How are you doing?
I'm doing just fine, Tim, and it's a pleasure to be able to talk to you not only from the space station, but from the cupola, which is the premier place to be if you want to take imagery of Earth and the surroundings.
You're exactly right. That's one of the top places, I think, anywhere known to humans so far to be able to do imagery in space. So that brings up, that's exactly what I want to talk to you about, because your work on the International Space Station and on the shuttle, doing photography and other work has been incredible. So I had a few questions, especially questions that a lot of people ask about photography in space and things. So I was hoping that maybe you could help me answer those questions. How does that sound?
I'm happy to answer any questions you want, particularly if it helps other people do better imagery.
Sounds fantastic. Well, let's start off. A lot of people ask, why don't we see stars? And even right now in the background, why don't people see stars in space? Is it, of course, they're seeing things like it's daylight right now for you, obviously. But can you explain that now, why that actually is?
It's really bright, and your eyes are dialed down. They're stopped down, and the stars are a lot dimmer than what the ambient lighting is. So even though the stars are there, you cannot perceive the stars with your eyes. If you had instruments you could measure, but the contrast between the bright and the dark is such that you can't see stars. It's completely different, though, after orbital nighttime, and then the stars come out in all their glory.
That brings up a good question. Let's say that you closed your eyes long enough to, have your pupils dilate to actually, be able to see the dim light, and you were looking away from the Earth, so it wasn't glaring everything out. Would you still be able to see stars pretty well, even if you're on the daytime side of the Earth?
That's a good question, and I can't answer that because I haven't done it. But that's something that maybe I'll do. I'll do the equivalent of looking through a toilet paper tube or a paper towel tube, where I can exclude everything in terms of the ambient lighting, but just where I am looking. Now, I'm going to give that a try and see what happens.
Oh, that's fantastic. It's just one of those things, it's a lot of people I don't think necessarily appreciate that just because it's black, in space doesn't necessarily mean it's nighttime, or the exposure, everything's so bright. I don't think we always equate that here on Earth, to meaning that no, they're still very dim. It's just that it's, so on that topic, can you give us a little rundown on the settings that you normally use when doing nighttime and orbital nighttime imagery on the International Space Station?
Yes, for nighttime imagery, I like to keep the shutter speed greater than a half a second. And that's because of not only orbital motion, but the pitch rate of station will make everything blurry. Earth will be blurry, and the stars will not be pinpoints. And so that is sort of the thing you have to set first, and then you got to tweak f-stop and ISO to suit. And at nighttime, you use the maximum aperture or smallest f-stop that's available to your lenses, and I like fast glass lenses that have small f-stops, f1.4 and f1.2, to me is the entry level for doing the nighttime imagery. And then after that, it's how much ISO or gain on your sensor chip. How much gain can you have and still keep the electronic noise acceptable? And that's what you're always juggling around. And 12,800 is typically the highest gain that I like to deal with. I prefer ISO 3200. And then with fast glass, f1.2, f1.4, and then a shutter speed of around a half a second. And that'll give you pretty good exposure for nighttime imagery.
That's fantastic. And so can you give us kind of a rundown on what would your normal settings be during daytime exposure? I assume it's the same, when you're shooting the Earth from space, it is when you're shooting the Earth from Earth, right?
Not necessarily. It's a whole lot brighter with your exo-atmospheric. You just look at the solar flux on Earth in, noontime summer, you're probably talking 700 watts per square meter. And on orbit here, low Earth orbit, we're talking 1,300 watts per square meter. So it's almost twice the intensity. And if a shaft of sunlight comes through the cupola window and falls on your face, you really know it. So it's really intense here from illumination, and about three stops brighter than what you would do for seeds on Earth. So the Sunny 16 rule, you need to modify a little bit by about 3 stops. And for ISO during daytime, I like to shoot at the optimum ISO for whatever sensor you have in your camera. For the Z9s that we use, that ISO from the reading I've done is right around ISO 500. So I set the ISO to 500 and then dial in. I like to shoot the lenses somewhere around f5.6 to f11, right in the sweet spot for their resolution, and then shutter speeds to allow that.
That I did not realize that it was actually brighter. I mean, that makes sense. So thank you so much for giving me that. That is fantastic. Can you?
Yeah. Okay, let me, before the next question, let me do an addition. It's nearly impossible to get good video in a place like the cupola because it's so bright outside and it's relatively dim in the cupola. It's all black because you want it dark. And the video camera, Earth and all the surroundings would just be snow white, washed out if you exposed it for the cupola. And if you exposed it for Earth and Earth views, then you'd be so underexposed you couldn't see anything. And what I did here for this mission, I got NASA to fly neutral density filters form cut for the cupola windows. And this is something that the Hollywood boys do. The big boys in Hollywood, they'll cover windows with neutral density filters to match indoor seeds with outdoor. And what we've done here with these filters that are on, there are 4 f stops darker. And if I were to, let me give you a demonstration here. I'm going to peel the neutral density filter off of this window behind me, and you'll see what happens.
Wow. Oh, that is awesome. I wondered how. I almost wondered if you had fill lights in there or something to make it so the cupola interior exposure was matched so well. But that is a brilliant solution to just put neutral density filters on the windows.
Yeah, and if we brightened the inside of the cupola to match the outside, it would be like sitting under a sun lamp, and you'd start to sweat, and your skin would be all shiny, and you'd look more like a lizard than you would a human being.
Oh, that is so cool. I did not even hear that you were going to be doing that, and it makes so much sense, and it's so cool to see, and it's so practical for doing videos like this when you want to try to get the exposure of both the inside and the outside. So Let me ask you another question while I have you on the gear side of things. What are Can you give us kind of a gear rundown on what you typically shoot with on most days, the cameras and the lenses?
Okay, for daytime photography, uh, I like I like this setup here. It's a Z9 with a Sigma 50 to 500 millimeter zoom lens, and this does an outstanding job of sort of capturing Earth views. If you really want to zoom in with a telephoto lens, then we have a series of prime telephoto lenses going from 200 millimeters, 400 millimeters, and we've got an 800 millimeter, and then you could put doublers on those. If you're just shooting for maximum resolution and effect, I'll go for a prime lens. If it's just gee whiz stuff, then I'll use a zoom lens. And then we have, let me reach over here. We keep 3 or 4 or 5 cameras in the cupola. This is a camera, a Z camera. It's set up with a 28 millimeter f1.4 lens. And during daytime, you'll do a series of wide angle shots as well as the normal focal length, say 30 to 70 millimeter, and then going into a telephoto.
That is so amazing. Is there any considerations that you need to have for these cameras as far as being in space? Do they have any radiation considerations or any other modifications at all? Or are they just literally out of the box and up they go?
Um, yes and no. They're not quite out of the box. For the Z9 camera, NASA's done a bunch of radiation testing. We're planning to take the Z9 or Z9 equivalent on the Artemis missions in the radiation environment in that kind of mission profile, going away from Earth, going through Van Allen belts, going to orbit around the moon and on the surface. That's a different radiation environment, and you need to have a camera which nowadays is mostly electronic, not mechanical. You need to make sure the electronics works. And then NASA gets special firmware written for the camera, a few modifications like image numbering. If you have a normal off-the-shelf camera, it is possible after a few thousand pictures to have pictures roll around and get the exact same number again. And NASA doesn't like that. When we have a mission like this, we'll shoot 500,000 pictures, and you don't want multiple pictures with the same image number. So that's just an example of a software mod that NASA has for the firmware so that the testing 1, 2, 3. Did we have an LOS? Tim, are you still there?
I am still here, Don. You're back and reacquired, so we're good to go.
Okay, let me also show you. I talked about daytime cameras. This is one of my favorite setups for nighttime. This is fast glass
at Houston Station. On my end, I could see that the wireless mic is giving bars on the camera, so I know the wireless mic system is working. Let me wiggle a cable or two.
A question: Do you are you picking up the wireless mic now? Okay, great. Well, uh, you know, technical things happen like that. We're in space and we're kind of out there in the frontier, and things don't necessarily work the way you want them to, like back home.
Absolutely. It's understandable, and I appreciate you continuing to work with me here. I have just a couple more questions, but while we still have a little bit of time, um, speaking of cameras and space and everything, are there any modifications? You're talking about Artemis with radiation and considerations. When actually going and using a camera in the vacuum of space, will there need to be any additional modifications made to the cameras to be able to handle that environment?
That's a great question, Tim. I was actually surprised that we take the cameras basically unmodified out into the vacuum of space, and they work just fine. Uh, we put a little garment around the camera that protects them from the sun, from overheating from the sun. So a thermal garment, and it keeps the camera from getting too hot. It keeps the camera from getting too cold. But in terms of protecting them from the vacuum of space, NASA doesn't do anything. We just take the camera, the lenses, and out the airlock they go with us.
Wow, that's actually pretty phenomenal. You'd think there'd have to be some kind of extra consideration, but that's pretty amazing. So I assume we'll likely see the same cameras that have been tried and true and tested on EVAs also be used on the moon for the Artemis missions.
That's correct, and we haven't taken the Z cameras out on spacewalks yet. We're getting ready to do that, and that will be the first level of testing, not only for upgrading cameras on station, but also for the Artemis missions.
Fantastic. Okay, I have one last question for you here while I've got you. And I was curious, can you kind of run us through? You've done some photos and videos transitioning, during sunrise and lunar sunrise and lunar sunset. Can you explain kind of how do you ramp the exposure, especially when it happens so quickly between the daytime and nighttime exposure? What are your tips for that?
Yeah, it's tough, and I'm still struggling with that. For on Earth, it takes 2 minutes for the disk of the sun to set. On orbit here, it's 7.5 seconds. So you go from full bright sunlight to dark, dark, dark in 7.5 seconds, and to keep a camera happy recording images through that transition is really tough. I've not yet been able to my satisfaction, record the day-night transition. But I hope to do that later on with this mission. I've got a couple of tricks up my sleeve where I'm going to be running two cameras simultaneously synced, and they'll be set up with radically different settings, and then afterwards a high dynamic range imagery can be ilked out of that. But I haven't gotten around to doing that. We've been busy doing our mission, and all this photography stuff just has to be done in your off-duty time.
That makes sense. Well, it's been absolutely amazing to see the work that you've done, and it really does, it makes it back down here on Earth, and people, it's so fun to see our planet from such an incredible vantage point. So, thank you so much for taking time to talk to me, and it's just been so fun to watch your career. It's just been amazing.
Well, Well, Tim, I learn from you and the videos and the instructions you make, and I notice you like to wear a baseball cap, and so in honor of that, I brought my NASA baseball hat, and I thought I'd put it on and show you.
That is fantastic. Thank you so much, John Pettit, for your time and your work. Greatly, greatly appreciate it. Keep it up.
You too, Tim. You keep doing what you do, and I'm going to keep doing what I do. It's been great talking to you. Bye now.
Bye-bye.
Station, this is Houston ACR. That concludes the event. Thank you.
And thank you to all the participants. Station, we are now resuming operational audio communications.